Alright, everybody, hello and welcome to chapter 2.3. I meant to put this into the big screen mode and then I just colored on it. See? That doesn't work when the pen is on. All I've done is color the button. Let's try that again. And let's actually hit the button this time. There we go. Look at that. Hey. Alright, so there we go. Chapter 2.3. We are doing solving, and more solving today. We're just increasing the difficulty, right? Instead of doing one step, we're doing two-step equations today. So what you're going to do today is apply, there we go, the method of solving equations to a two-step equation. So what we did yesterday, where we're doing inverse operations to isolate a variable with equivalent equations, we're doing that again today, except now we're doing it with multiple steps. So let's take this example here real quick first. This x over 2 plus 5 equals 11. Okay. Notice that involves two operations being performed on x. There's the division by 2, right? So this division by 2 is what's happening right there. And then there's also the addition by 5. So the addition by 5, which is happening right there. Typically, if we were to be plugging a number in for x, what we would do, like say we were just doing this expression and saying, we had x over 2 plus 5 and x is 6, right? X is equal to 6. And so typically speaking, you would go like this, and you would do the division first. That's 3 plus 5, so that's 8. However, when we're solving and we're going with an equation, we're actually going to do when we're applying the inverse operations, we're actually going to do the reverse order of the order of operations. So order of operations down here says that we should divide by 2 first and then add 5. That's if we are doing this, right? That's if we're doing this right here. If we're using order of operations to simplify. But if we're solving, and notice the different word that I used there, right? If we're solving, we're going to go the opposite direction, okay? Instead of doing the divide by 2 first and add by 5, we're going to use inverse operations and go the opposite direction. So we're going to subtract 5 and then multiply by 2. So let's actually do that over here and go x over 2 plus 5 equals 11. And let's work vertically, because I know you guys like working vertically more than you like working horizontally. So the first thing we're going to do is the opposite operation to this plus 5 right here. So we're going to subtract 5 from both sides, and then we're going to rewrite the expression that we had left. And again, I am going to absolutely insist that you are showing this step, okay? You need to show me the equivalent expression, or excuse me, the equivalent equation that you get after you do a step. The problems that we're going to be doing in the future might have 3, 4 steps to them, and every step you need to rewrite the equivalent equation, right? This thing is the equivalent equation because it's a different looking equation, but it's going to have the same solution to what we did because we did the same operation to both sides. I'm going to insist that you do this, okay? Last step, since we're dividing by 2 here, we're going to multiply by 2 here, and so the 2's on the corners cancel each other out, leaving 1x, just the x by itself, and then that's 6 times 2, so it's 12. And my final answer, since I have the x by itself, is 12. We can do a couple other examples here of various things that we might have to do for an additional step. For example, 7x minus 4x equals 21. Notice that these over here are like terms, right? Which means that they can be combined. We don't need to do an inverse operation here. We're just going to combine those two terms because they're both x terms, and therefore we can just combine them. So we'll divide by 3, we'll divide by 3. The 3's here cancel each other out, leaving only the x, and then we have 21 divided by 3, which is 7, and there's my final answer. X equals 7. Let's do one more example. 2/3 x plus 4 equals 11. So we want to do this again, opposite operation. So we're going to subtract. We're going to start by subtracting 4 from both sides. When I do that, 4 minus 4 is 0, so it goes away. This is 2/3 x equals 7. And then just like we learned yesterday, when we have a fraction multiplying the x, to get rid of it, we're going to multiply it by the reciprocal. And I would say yesterday about 60% of you got this right on the first try. So that's why we need to do a little bit more practice with it today. So we're going to multiply both sides by the reciprocal. That's 3/2. We'll multiply this one by 3/2. Remember that they cancel on the corners. They cancel on the corners. So that all cancels out, leaving us with just an x. And then on this side, we have 7/1 times 3/2. So 7 times 3 is 21, and 1 times 2 is 2. So x equals 21/2, and I should just check to see if that simplifies at all. 2 and 21 don't share any common factors, and so that's it. Leave your answer like that. Again, remember, improper is fun, so keep your fractions improper. All right, finally, another context question for you. So a scuba diver descends into deeper water. The pressure of the water of the diver's body steadily increases. So, like, let's draw a picture of what's happening. Okay, so here's our water, right? And our scuba diver, here's our scuba diver. Here's Scuba Steve. Hi, Scuba Steve. Scuba Steve is going into the water. There's a snorkel right there. He's got a snorkel underwater. Obviously, the snorkel's in the water right there, so that you know, he can just drink the water because it's not helping him breathe at all. Here's his air pack. Right? He has an air pack too. There's the air pack that's helping him, you know, not die. Okay, so as he goes more and more underwater, the pressure from the water, because there's just all this water on top of him, is going to be steadily increasing. So when he's at the surface, there is 2,117 pounds of per square foot. And that as he goes down, every foot he goes down, it's going up by 64 pounds. So for every foot that he goes down. So we got to find out, well, find the depth at which the diver experienced the pressure of 8,517 pounds per square foot. So we have to represent this as a fraction. Or not as a fraction, excuse me, as an expression. So how can we do that? So it starts here at 2,117 pounds, and then it's getting bigger by 64 per foot. So it starts here at 2,117 pounds, and then we need to add on to that 64 pounds per foot. So if it's going every foot, that's going to be 64. But then if it's like 3 feet, it would be 64 times 3. But since we don't know the amount of footage, we're going to just represent x with feet. So we know that the way that the pressure is growing is going to be like this. And we're looking for the number of feet that he would have to go down before it was equal to 8,517. So there's our equation. That per foot is in the way. I'm going to erase it. There's our equation, and then let's go ahead and solve it. So I'm going to subtract both sides by 2,117. 2,117. Ooh, man. Okay, can we do that in our heads? I think we can do that in our heads. The 17s match up, so that's going to be 0, 0, which is super nice. And then that's a 4, and then that's a 6, so 6,400. Oh man, look at how nice these numbers came out, right? 6,400 equals 64x. It's almost like somebody planned out these numbers so that they would work out ideally for what we needed to do, so we didn't have to use a calculator. I'm not saying that somebody did, right? Maybe it's just, you know, divine intervention here, divine mathematical intervention. But, you know, probably not. So I'm going to go ahead and divide by 64 to get the x's out of the way. 64 over 64 is 1. So that is simply x, And then 6,400 divided by 64. Well, let's see here. I think with the two zeros here, that's just going to be a straight up 100. So at 100 feet, we are going to have a pressure of 8,507. Hardest part of this problem is typically almost always creating this, right? Personally, I think it really helps to understand the situation to draw a little picture. This is why I drew Scoot to Steve over here, because it helps us understand what's happening so that we can create this equation a little bit easier. Right? And that's it. It's over. Woo! I've got, again, a quarter sheet for you somewhere in the room. Just go back to your Google Classroom and read, and you'll find out where it is. It's always fun to see who's obviously not reading because they're wandering, they're looking around at what other people are doing, or they're doing things in the wrong order or something like that. I find it hilarious because all you got to do is read what's on Google Classroom. All right, anyway, have a good day.